Hi everyone, my name is Lauren Rochetti and I am the marketing coordinator at Aventec. Aventec has supported many Dassault system brands over the years as a value solutions partner. We provide digital tools that help you get connected throughout your development lifecycle and entire supply chain. Our goal is simple, to bring the right tools to the best talent so you can turn purchases into productivity and ultimately profit. Today we're going to be talking about how saving time on managing assemblies allows you to increase productivity. Assemblies can get quite large for any real product, and managing them, especially with engineers, approvers, leads, and everyone else in the design, can quite get very messy. Joining us today is our speaker, Shashank. Shashank started out as an aerospace engineer, getting his first break at Bombardier as an electrical harness installation and designer. Throughout the years, he's held multiple positions and started teaching at Aventec and Dassault customers such as Spirit AeroSystems, Fiat Chrysler, and Boeing, to name a few. He has designed content, taught classes, and now to share with us easy and efficient design management, here's Shashank.
Thank you, Laura. I want everybody to imagine being really hungry. And now imagine three restaurants that all serve burgers within a 1 block radius of each other. Now, before deciding where you're going to eat, you're probably going to check the Yelp reviews. And what you find is one restaurant says the reviews says the place is beautiful inside, but the food takes a little too long. Another one says the service is not so bad and the place isn't so bad inside either. And the final one says service is really friendly and food you get it pretty quick. Notice how none of these reviews talk about the actual quality of the food, just the experience of being there. Now, what I want you to consider is if you're hungry and you're on the lookout for some food, which restaurant would you rather go to? Most of you would pick two or three, and it would probably come down to price. Now, think about which restaurant would you rather be, and I guarantee you would want to be the third kind of restaurant. This quote by the McDonald's founder, Ray Kroc, it really resonates with me today because I've worked in a lot of teams. And what I've seen is the teams that are able to succeed consistently are those who are able to work effectively and efficiently over and over again. And to do so, you need the correct kind of framework, which is what brings us to our topic today. If you want to be that third kind of company, if you want to be the kind of business that's able to dedicate more time into getting new customers and exponentially less time in dealing with existing customers, and you want to be able to do that in a lean and efficient way, then you need to make some serious considerations regarding the way you manage change. For design companies, for assembly design companies, that means you need to move away from the traditional assembly design model and adopt a model that allows you to make change effectively, which I'm going to present to you as a skeleton methodology. I'm going to talk to you a little bit more about how do you manage change using things like publications in skeleton methodology. And ultimately, I'm going to finish off today by telling you about why do you need and who do you need to be within an organization to leverage this to still be profitable and still have high quality work. Now, if you take a look at a typical assembly design process, you're going to start out by defining what a part is supposed to be doing. So at the part design level, you'll be defining what the specifications are going to be, size, form, fit, function, things like that go first. You probably define some acceptance tests later on as well. Then you go into the design phase where you first start out with some preliminary design, then some high-level design, and ultimately you're going to iterate detailed design until you have a releasable part. And once those parts are released, then an assembly engineer or manufacturing engineer can take those parts, put them together to see if those parts actually fit together within the tolerances. And then they create things like assembly instructions, which goes on to methods and down to the production floor. Now, assembling a tool like that or assembling any kind of assembly like that, it's simple and intuitive until you encounter the dreaded change. If you have to make any changes at any part level, effectively you've got to go all the way back to the beginning of the process. Now, this sounds fine until you realize a typical assembly that goes in larger systems has close to about 1,000 parts. And the process keeps repeating itself with the same amount of length, which means every single time you have to change a spec, you've got to go and change the design. Then there's a release process. You have to wait till all of that is done before you can use the latest and most current versions in the final assembly. Right? It's too time consuming. Another thing that happens when in working in big companies or even small to medium-sized companies is design takes many faces, right? Well, there's a specifications, requirements, and standards group that defines what needs to be designed and how they need to be designed. The design itself can be separated into structural design, where you design, structural components. For instance, on an aircraft, you think about things like the flanges or the stringers or the hangars where pipes or systems go through. Then there's the actual installation design, where you would put in your wiring, your harnesses, your piping, your tubing, your auxiliary or your drop-in black box systems. And finally, there's the manufacturing sector, which effectively takes the designs that you've made and creates their own work instructions to either treat the part correctly, to manufacture it, to ship it out to your customers, right? And effectively, you come into the situation of way too many chefs who are trying to work on the same design. Now, too many chefs can't work on the same product, the same dish, but many engineers can definitely work on the same product, but you have to realize, how long would you wait for something to be done correctly? And do you have early enough oversight if something needs to be changed? If the answer to either of them is waiting long and no oversight, then you're seeing a big failure point for the traditional assembly design method. Another problem is when you decide to link parts to each other. Now, it sounds extremely intuitive to link a detailed part to a subassembly and then the subassembly to the assembly. It's effectively like playing Legos. And while Legos are cool, you can't build an airplane like a Lego, right? When you design parts or design assemblies with part-to-part links, effectively managing those links become extremely painful downstream. And if you have part-to-part links, is updating links becoming a problem for you, which as you get into larger assemblies, you find that they tend to become pretty hairy when you're trying to resolve them. Another big loss. And one of the biggest problems I find with this method is version control. Let's say, for instance, you've got two sample designers working on a particular design, and from those designers it goes to the reviewers and approvers, and then let's say management has a copy that they want to show to higher ups or customers or whatever the case may be. Effectively, everybody has a copy on their own machine. There are way too many versions, and how do you know which version is the most updated if change has to trickle down or trickle up? And if you don't know that, how can you be sure consistently? If these take too much time in your operations, this is a huge loss. That's why I'm here to introduce skeleton methodology, in which parts are built in context using the part design app. What that means is the skeleton lies at the center of the structure, and around it, all the parts are built. So since everything is built around the skeleton, you don't really need any assembly or constraining, because it's kind of like going to buy a tuxedo or a suit or a dress and having it made around you, as opposed to buying one off the rack and amending it or fixing it or altering it later on, right? Which one do you think is going to fit better? And finally, making changes across the entire assembly is much simpler using this methodology, because if you want to change the way the assembly behaves, simply change the skeleton and the assembly will change automatically. So at the heart of this methodology lies the skeleton. It's the most basic form of the assembly. Think of the human skeleton. It's just bones, and it tells you how a certain body looks and behaves. It usually have points, lines, planes, surfaces that define the shape or master surfaces, and you'll have some key parameters. Parameters that tell you angles, size, or distance between 2 points. And you'll also have something known as publications. I'll talk about publications in just a second. Effectively, the easiest way to think about publications is to think about nicknames. When you give certain people nicknames, it's because what they mean to you. And same thing, you want to give points, lines, or planes, these basic skeleton features. You want to give them nicknames or publications, so it's easier for you to identify what role they play in the job you're trying to perform. So you can call points hole centers, part centers, or you can call lines center axes, or you can call surfaces bounding surfaces or tool travel surfaces, whatever the case may be. And it's also key to label or publish your parameters, because it's easy to work with published elements, because then the only association you have to your skeleton is the publications. and they become the perfect middleman to make any changes, right? For instance, this example tool that we were designing for a course at Boeing, you'll notice the drill peg on the left right here. That drill peg was designed in context to the center axis. We only have one publication that relates to that first center axis as its reference. But I want to change that. I want that publication to actually point to this center axis. This should be the new center axis. So I'm not going to change the publication. All I'm going to tell the publication is instead of pointing to the first one, you're going to point to the second one, and boom, the design, it's as if the first design never existed, and it's now placed in the correct position. Traditionally, using assembly design, you would effectively have to remove the constraints and then reconstrain it, but here, none of that is required. All you need to do is say, you peg axis, you are now looking at the new center axis, the new line as your reference, and boom, changes are done, right? And that's why managing changes such as parametric changes, let's say you want to make changes to the way the sizes are or the dimensions, scaling factors, that's easy to do. If you want to make any design changes that deal with the actual shape of the object, that's also easy to do. So you want to change, let's say, cylinder to a box or vice versa. Or you want to change the relationship of the skeleton itself. If you want to change the entire framework, you can do so. And managing that change is really simple. In fact, in some situations, if you have to use a different skeleton entirely, you can, if you've done it right, you can actually replace the skeleton and the entire assembly will shift and move to the new skeleton. So it's really cool. So the three main issues I had with traditional methods was that you couldn't work concurrently, that you couldn't do links properly, and that maintaining versions was tough to do. But in relational or skeleton methodologies type design, you're able to design simultaneously. Everybody can work on their own part at the same time without getting in each other's way. You can link to the skeleton so that you're never making part-to-part links. And finally, you've got a single master version, which means there is a single source of truth in your assembly. There are no multiple versions because everything works off of one object, one skeleton, and one assembly. Win, win, and major win. So now you must be thinking, thanks to this awesome technology or awesome methodology, how do I get on this and save time now? Well, before you do that, you should first ask yourself, where do you see yourself using this? Is this right for you? And generally, skeleton methodology works best when it's done in a collaborative way, where you have multiple people working on the same design, multiple people across this entire supply chain who need access to that design. And you could be anybody within the design supply chain. You could be a designer, structural designer, you can be an installation designer, mold and tooling engineer, robotics engineer, sheet metal engineer. You could be a reviewer, design reviewer, somebody who just does approvals. You can be management, you can be executive leadership. If you need access to this, if you provide value or derive value from this assembly, then you can leverage skeleton methodology, right? I would like to thank everybody for listening to this very short talk. If you have any questions, feel free to send us an email, and I'll pass you off to Lauren.
Well, thank you again for everyone who's watching. If you have any questions or you find yourself losing time and money managing large assemblies, please reach out to us by email or give us a quick call at the number that you see on your screen. And in addition to this webinar, you'll be also able to be interested in our blogs that we post weekly for any tips, tricks, and solutions to any industry problems at our website at www.aventec.com. Take care. Have a great night, guys.